Rapid advances in information technology are giving rise to new applications such as cloud computing, AI, IoT, 5G, AR, and VR. Data volume is thus growing exponentially, now ranging in the zettabytes. That's 10 to the power of 21 bytes, or a trillion gigabytes. According to estimates, global data creation is expected to grow from 33 zettabytes in 2018 to 175 zettabytes by 2025. By the same time frame, 6 billion users, or 75% of the world's population, are expected to come online, while 75 billion devices connect to the Internet of Things. Meanwhile, the proliferation of cloud services is driving explosive growth in data volumes at the data center end, causing a spike in power consumption and total cost of ownership for cloud service providers. As shown on the left, data centers alone are expected to account for 15% of the world's energy use by 2025, while the amount of power needed to run and cool a server rack continues to grow steeply. This also has adverse environmental implications, for which all major cloud providers are making a concerted effort to reduce their carbon emissions and convert to green energy sources. As mentioned, growing power consumption at data centers is not only driving up TCO, but also a direct threat to the environment. Meanwhile, memory is expected to account for a substantial 20% of server power use in 2022, and 35% by year 25. This calls for high-performance but low-power memory systems that process data more efficiently, as the very key to reducing data center TCO and preserving the environment, now more than ever. There are two possible directions to delivering the memory we envision. One would be to seek continued performance and power improvements with existing memory for greater value and sustainability. The other would involve creating entirely new solutions along the memory hierarchy, such as processing in memory, CXL memory, and near data or in-storage processing. DDR5 is more power efficient since it uses less energy per 1 bit than DDR4. In other words, DDR5 provides 1.5 times and 2 times the bandwidth over DDR4, while it requires 17% and 21% less picojoules of power per bit, respectively. Thus, DDR5 does provide faster speed than DDR4, but it also consumes less energy for 1-bit transmission. DDR5 achieves efficiency and performance improvement by structural enhancements and new refresh schemes called fine granularity refresh and same bank refresh. With structural enhancements, DDR5 provides 20% improved effectiveness even for the same speed with DDR4, and 70% for the faster speed, which means the actual higher gigabytes in practical use. And compared to 1 times refresh, fine granularity refresh, and same bank refresh support better bandwidth of 1% point and 5.2% point respectively. It is because those do enable refresh time to be shorter than 1 times refresh. The forecast for the trend of higher density DRAM die shows that the need for higher capacity memory would persist for years to come. As for DDR5 DIMMs, it can be composed of higher density dies which are 32 gigabit. And those can also make up for newly emerged density demand for odd density, which is represented by 24 gigabit die. ROS is one of the most important features in modern computing systems. DDR5 was designed with great care for this requirement and provides a successful response. With onboard ECC, DDR5 covers most single-bit failures before they develop into system errors, which translates into a significant decrease in probability of detected uncorrectable error. DIMM solutions based on DDR5 come in 2 options for greater user choice: the standard x80 configuration with the added capability of SDDC, or System Error Correction Support, and the Time72 module, which allows less components on the DIMM for cost saving. So, how much actual value can our solutions create for the environment, society, and tomorrow? Take DDR5 and HBM3. SK hynix's DDR5 DRAM, the world's first launched in October last year, doubles the bandwidth over DDR4, effectively allowing the same or greater system performance to be achieved with a smaller amount of servers. Our HBM3, released in October 2021 with world-leading bandwidth of 819.2 GB per second, can process the same workload as DDR4 DIMM with 20% less picojoules of energy per bit. Then about CXL memory, which is drawing high expectations as a potential game-changer in the data center landscape. CXL memory will offer scalability of capacity and bandwidth, as well as an added persistency feature in a dedicated type. Tiering or pooling memory with CXL in server systems can allow overall memory resources to be used flexibly and efficiently at less power. Furthermore, using CXL memory can save valuable wafer resources, as fewer wafers are required to build the same capacity modules thanks to the higher bits per wafer possible for high-capacity CXL memory and device yield improvement with the use of controllers.